Hello, welcome back to Blender Sushi LIVENODING. In this episode, we're gonna continue one more thing with our Voronoi Fracture setup on 3D box. So it's still the basic bit. We don't use like a random 3D shape yet, just box. This is what I had last time. So I'm gonna add one more thing. So I think I haven't touched that bit. So just load the zip from this link and simply load it into Blender, and we get the whole setup ready for us. And last time we are able to do the rotations using um, the vector here, using the matrix in, but here we have the ability to scale the objects, and we also have the ability to move the objects. And but there is one more thing. I'm gonna add rotation up here, and let's investigate what we can do with this. So of course the scale, move, and rotation here is gonna work for every fracture object. So it's kind of like a grouping of the vertices, and it is also a center pivot because of this move. So yeah, this is supposed to be pretty self-explanatory. So if we can really rotate this like all of them at the same time, or we can also randomize them if we use like random vector. Currently we have 12 pieces of Voronoi Fracture down here, so assign a 12, number 12 there, and we can actually separate this for each one of these vector out. So 1, 2, 3, randomize the seed, scale. So that's in itself is quite interesting, I found. We can zero it out, and here also we can zero it out. Now we have it's still being rotated somehow. Okay, that's strange. Maybe I forgot something. Maybe delete the rotations, go back to this guy. Oh, actually that guy wasn't rotated. It's just it was being scaled. Maybe I should turn off the scaling as well. But anyhow, there's one interesting part that we can investigate here. It is the locations. So the rotations, yeah, we can randomize rotations, but rotations is not like yeah, rotation can be interesting as well, but for now let's do the locations. With locations, if we use a single value, you can see that we kind of move the whole objects. But what's gonna happen here is that if we supply the matrix transform for each objects, we can actually kind of push these objects out from its original position. It is currently on its own position, and but we can, if we supply like a random vector, currently we have 12 pieces. If we have like 12 random value here, and here instead of a single value, if we say use a vector LERP, linear interpolation, don't use the evaluate, use the LERP in this case. So here we have like a random value being of just random value is pushing it in with scale set to 5. Let's plug that in, and this one with scale set to 0. And what's gonna happen, you will see that we can kind of have this kind of animations. which is pretty cool. This should actually practically works if you have like basically if you have like a bunch of objects like this, and you kind of join them together, Control J. Now it is single objects. If you have objects like this, which is a single object, it can be made up like 1,000 pieces. You can simply bring these objects into sphere chalk, and then once you separate the objects from here, you can basically treat the whole thing like this. Once you have like procedural animations taking advantage of this grouping of components, and then you also have control over each pieces using this transform matrix, you can end up with pretty cool animations basically. So you have this this setup for VECTOR LERP. This vector, of course, you can also kind of randomize it. You can procedurally control each pieces, so it's coming like one by one instead of all happening at the same time. So let me try something. So currently we have this scaling animations. Let me turn it off. Scaling is coming from this guy. I'm gonna make a route and then gonna cut it here. Factor set to 1, so it's not scaling anymore. But this value we can plug into the LERP, and now okay, now it's doing the lerping. Let me think. We might need to separate the value of this guy somehow, or maybe I need to join it. Just list join this guy. So the lerp now should be happening one by one. So yeah, this is what I say. This is like a super interesting kind of animations, and like I said, if you have like a bunch of objects like this, you simply join them, Control J. Now it's single objects. If I'm not wrong, if we just bring in into this guy, everything's gonna work automatically. I might be wrong, but you can give that a try. So yeah, so now we have this animations just simply by animating the positions matrix of each Voronoi fracture. There is also this scaling that I have not touched. The scaling is not happening. The pivot of the scale is actually in the center of this 3D cube. So if we use like a vector in just a single value into this guy, you're gonna zero everything out. But see, you can kind of do the stretching and whatnot back here, and you still have the animations working. And because this is a procedural setup, you can always kind of go back, randomize the seed back here, get a different fracture objects, and all the animations will still work. So yeah, I think this is really powerful, and glad that I'm happy that I can share this with you. Some of these concepts I'm also like still learning. It's not easy, but if you understand this, it's kind of very powerful. So with a count here, we need to make sure it's the same for every single one. So this length, this one is very important. From these points for the Voronoi fracture, the total number needs to be plugged into this guy as well. So if we say, okay, we want to have more fracture, we can increase the number, and now we still have all the animations happening. Of course, if you look at some older videos, I actually at some point I talk about how you can control the sorting of these numbers as well. So you can kind of orchestrate it, the fracture, maybe start from here and then end up right here. And you can also use grease pencil to control how the animation is going to be ordered for each pieces. Currently it's like pretty much kind of linear. It's like one by one goes into the positions, but you can always randomize it in here. Let me think. Okay, this is add, goes in here. You can use a noise, if I'm not wrong. Noise. So we have LERP going in here. Vertices. This is for the scaling. And let's see, the number. We need some kind of numbers to further randomize this guy right here. Maybe just add some random number or noise down here. Random number. Plug this guy in. And what's the size? 21. So this will actually further randomize the animation, so it is more natural. So split minus 100, add. Yeah, I think they gather slightly more random now. So that's if you want to do that. Otherwise, don't worry too much about it. You can use the easing, which is pretty cool. So this range, of course, between 0 and 1, if you plug this into these functions, easing functions, we're gonna be able to have kind of like ease in or ease out, things like that. And we can use this with this vector lerp. The vector lerp goes between 0 and 1. Be careful with that. So you might need to do the remapping here. So original 0 to 1, just remap it actually 0 to 1.5, and we can remap it to 0 to 1 value. Turn off clamping, and hopefully this will work. Oh, actually, maybe we need to turn off clamping. Turn on clamping, and okay, that's a little bit strange that we need to go minus there. Back is in, maybe bounce. Elastic is in. Let's try. Back is out. I think it's pretty good. So we have that kind of extra animations for free. Goes in there, and we can slightly rotate it so it's not like perfectly. Don't worry about that. This scaling speed off. Clamping on, off. I don't know why this is not 0. Oh, because the seed is different, that's why. No, that's weird. Okay, stethoscope. Let's check the number down here. That's supposed to be 1. Okay, so yeah, I guess this is a bit weird. Clamping off. Let's try back is in and is out. Yeah, I think it is working like this at the moment. 0 to maybe 0 to 1.5. Oh well, we need to just play around with this number. Sometimes I get confused with